So I'm going to solve some examples on 9.4. So the first one here, he's stating that there's a radio telescope has a circular. So this circular thing means that I need to multiply the equation of the critical angle by 1.22. Collecting dish of diameter. So the diameter of the aperture, which is B, is 5. It is used to observe two distant galaxies that are both emitting electromagnetic radiation of wavelength. So this is the wavelength. The image of the galaxy are just resolved. When he say just resolved means that, so if these are the two galaxies, let's say, then the angle subtended from the galaxy toward the telescope here, this angle is equal to this angle, which is equal to the critical angle. So in this case, he's saying what is this? So here he's asking for the angle subtended by the galaxy at the telescope. So how am I going to solve this? The angle is going to be equal to the critical angle, which is equal to 1.22 times the wavelength over b. Now it's just a matter of converting units and doing the math thing. So lambda is 20 times 10 to the power of minus 2 and over 5. So 20 over 5 is 4. 4 times 1.22 is 4.88 times 10 to the power of negative 2, which means that it's 0.05 radians. So this is in radian, but if you move the decimal place like 2 decimal places, you will end up having this answer. Another question, the headlight of a car emit light of wavelength 400 nanometers. So this is the wavelength. And are separated by this much. So this is the distance between the two headlights of a car. So this is D. You have to distinguish between D and B. Okay. The headlight are viewed by an observer. Usually the eye is a circular aperture. Okay. And he gave you the diameter of the eye. It's 4 millimeters. The observer can just distinguish. So the angle subtended from the headlight. So these are the headlight. This angle, okay, which is equal to the angle between the two maximum, should be equal to the critical angle, because he said just distinguished. Okay, what is the distance between the observer and the headlights? So he's asking about this distance. So the observer eye and the headlight, he's asking for this. Okay, so we know that this is D, here it's B. So all what I have to do is to use the B, the diameter of the eye, with the wavelength to find the critical angle, and then from the critical angle I will use the small angle approximation, which states that this angle is the opposite over the adjacent, and I will be able to find D1. So try doing it on yourself. If I'm going to do it here, so it's going to be theta c equal to 1.22 times lambda. Usually the students forget to add this 1.22, and here where's the answer vary. So here I converted from nanometers to meters over B, and B is in millimeters, so times 10 to the power of negative 3. So this will take the value of, here the 4 will be cancelled out with a 4. The 10 to the power of minus 3 will get up with these two zeros as 10 to the power of 5, which means that the angle is 1.22 times 10 to the power of 4, I guess, yeah, it's 4, negative 4 radians. So this is the angle, but he's not asking about the angle of separation. He's asking about the distance. So to find D, theta c is equal to D over D1, which means that D1 is D over theta c, which is equal to 1.2 over 1.22 times 10 to the power of minus 4. Of course, I can't use calculator. Okay, I can't use calculator, but in this case, I will estimate. So 1.22 over 1.2 over 1.22 as if it's 1, okay? 1 times 10 to the power of 4, which is 10 kilometers. So here I'm approximating. So this is the answer for this one. Now, some paper 2 questions. Here he's saying state the Rayleigh criterion for resolution. Of course, this is part of question, but we will be seeing the rest of it in previous in another video. So here, if you are asked to state what's this criterion, all what you have to do is to write that is when central max of the diffraction pattern is on the first minimum, or actually let me write it in another way, in a better way. Okay, so here I can write it as so when the central max of the diffraction pattern of first object is on first minimum of diffraction pattern of the second object. So this is the Rayleigh criterion. Now let's do some solving here. He's saying the painting contain a pattern of red dots with spacing of 3 millimeters. So this is the distance between the two red dots. Okay, so the painting contain a pattern of red dots with spacing of 3 millimeters. So this is the space between two dots, okay? So I'm going to say that this is the D. Assume the wavelength of red light is this much. The average diameter of the pupil of a human eye, so it's a circular aperture. Calculate the maximum possible distance. So this is the same as before. So he wants the maximum possible distance at which these red dots are distinguished, which means that the angle should follow the Rayleigh criteria. So in this case, we know that theta c should be equal to 1.22 times the wavelength over b. Okay, and it's equal to the distance between the two red dots over d, and this d is the one that I need to find, which means that d, it's equal to the small d times the small b over 1.22 times lambda. Now I need to just substitute, so 3 times 10 to the power of minus 3 times 4 times 10 to the power of minus 3 over 1.22 times the wavelength, which is 700 nanometers. So I need to use my calculator here to find the answer. Let me use it quickly. So here it's going to be 3 times 10 to the power of minus 3 Okay, so the answer for this one is going to be 3.5 times 10 to the power of minus 9. So it's a 3.5 times 10 to the power of minus 9, and the unit here is in meters. Okay. Second question. Light from a point source is incident on pupil of the eye of an object. So here there's a point source, one point source. The diameter of the pupil is 2.8 millimeters. Draw on the axis the variation with diffraction angle, which is in radian, of the intensity of light incident on the retina. So here you have to pay attention to two things, especially that this question is out of 2. The first thing that you have to pay attention is that if you are choosing the maximum to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units, so here the intensity is 10 units, okay, the maximum intensity or the intensity of the central max, then the intensity of the first max should be only 10% of this. Yani it should decrease by 90%, so it should be something like this. And of course, there's something else that you have to pay attention to, which is the width of the minimum. So here of the maximum, sorry. So here the central max should be double the width of this, okay, of this and this. So the first mark goes for this one. The second mark is for the intensity. So this one is only 10% of this. Estimate in radian the smallest angular separation of the two distinct points. So if there's two distinct points of light of wavelength, so this is the wavelength that can be resolved by the eye of this observer. So the eye of this observer has a aperture of 2.8. So in order to find the angle, the angular separation, it needs to be equal to the critical angle, which is equal to 1.22 times the wavelength over, I guess it's 2.8 times 10 to the power of minus 3, and you just use your calculator to find the answer. Okay, so that's it. If it's not a circular aperture, you just don't add this. So I guess this helped you understand more topic 9.4. So that's it for today.